Ladies and gentlemen, Redis geeks and geekettes, welcome to Redis Day.
Hello, my name is Dima Vizelman. I am working in Kenshoo. I am going to tell you about Jesque-based delayed periodic queue system. Jesque is the Java project using Redis Java client in order to connect Redis. And the specific microservice I am going to tell you about is Performance Aggregation microservice. So what I'm going to speak about, I will give you the brief intro into the analysis application, the application that uses the microservice I'm going to tell about. Then I will show you the requirements we have from aggregation server requirements, the requirements we were set to. Then I will show you the proposed solution that will meet the requirements. We'll give the solution overview. And then I will dive a little bit into the key features of the provided service. So what is analysis application? Analysis application orchestrates advertising across search platforms. So here you can see main window of the analysis application. Analysis application displays to the user all kinds of different search metrics like conversions, clicks, and those metrics should come in aggregative way. So we are allowing to our customers to provide date range. So here, where the aggregation service comes to life, aggregation service actually gets the request from the analysis application and actually performs the aggregation of the performance data to be used by the analysis application. So the flow would be as follows. We are getting pointer. That's it. We are getting a request from the analysis application. Request goes to the performance aggregation microservice. Performance aggregation microservice checks whether we already have such aggregation in place. So if we have such aggregation, we are returning the answer to the analysis application. Otherwise, we are issuing aggregation job. Aggregation jobs actually goes to the database, brings all the needed data, aggregates the data, creates the new table with the aggregated data, and makes the analysis server know that the data is ready, what is the table that contains the data, and this way allows the analysis application to go and use the data. We have different types of aggregation types. We have on-demand, user-initiated aggregations, just like you've seen in the flow before it, or we have scheduled data. Why do we have scheduled data? Because of users usually needed the aggregation above some known date range, like last day or like last week. So we know in advance that we may prepare the data for the user. So user will not need to wait for the data. So scheduled aggregation are running from the point we are getting all the data to the point that users use the data at the morning when they are coming to the office. So we have some hours that we can schedule the aggregation, and we can actually perform the aggregation, perform the calculation. So we need immediate, on-demand request, and we have scheduled request as well. Now the request may be lightweight or heavy, depending on the amount of data we use, depending on the data range. things like that. And data can be in real time, or aggregation can be real time or delayed. Real time in case of user aggregation. Of course, we wouldn't like our users to wait for aggregation. In some cases, we would like to have delayed aggregation. I will go into it so that's what the brief into the analysis application. The requirements we got were where we have 500 analysis application. We've got 2,500 scheduled aggregation per application, and we need to supply the answer to 200 user requests every 5 seconds. And we would like no C to performance degradation. We would like to provide minimal response time for the user, as it's the real-time application. User asks for the data and expects the data to arrive as fast as possible. So our UX should say the same, exactly the same in peak hours. And out of peak hours, we should handle the failures in the good way. We should handle the failure of specific aggregation and should handle the failures of the entire server. For example, some crash, something unexpected, and we should be able to work in cluster. We should be able to use environment that the proposed solution was the use to Resque and Jesque. Now, Resque is the Ruby library that allows us, originally, a Ruby library that allows us to create background job, to put background job on multiple queues, and to process them later. Jesque is the Java implementation of Resque, and Jesque uses the Java client in order to Java JDIS client in order to connect to the Redis. So why Jesque? Why Jesque among all others the solutions? First of all, it's simple. We were able to have POC in a matter of hours integrated into our system. We were able to check our requirements, and we are able to see that actually the system works fast, actually much faster than we needed. Our requirements were lower than the things that Jesque system provided. It was very fast to put the jobs into the queue and to draw the jobs from the queue. It was very robust. We were able to run long times without any need to reconnect. We are able to work with the servers that were go down and up, network failures, everything. The things worked perfect. And the system actually give us all the features we needed. We wanted priority queue in order to user request to be served before the scheduled request. We wanted delayed jobs. We wanted some job to be set on the queue but executed actually later, not to be shown to the workers at the moment we are putting the job to the queue. And we get work in the cluster distributed environment. So that's exactly what we asked for. So the solution overview looks like we get API call from the analysis application to our microservice. Our microservice checks whether it needs to aggregate data. In case it needs to aggregate data, it puts the job into the Jesque, and then one of the workers on one of our cluster draws the job and calls to aggregator, which actually does the job. So this way, we actually were able to provide end-to-end solution to the customer. Now, the key features of provided service is the priority queue. Priority queue was implemented in the Jesque in the way that actually the priority is set not on the job, but on the queue, which means that at the moment the job arrives, we are classifying the job, we are deciding where the job should be high priority or low priority, which is rather easy in our case because high priority actually is the user request and all the scheduled requests are the low priority. And then we are putting the job to the appropriate queue. Jesque guarantees us that the high priority job from the high priority queue will always be executed before the jobs from the low priority queues. So in this way, we are guaranteed that the user requests are given priorities and executed before the scheduled request. Actually, it's rather simple solution, rather a solution that was acceptable for us. We were happy with the solution. All the workers on the clusters are actually looking on the same queues, which means we have 2 queues, and we have many workers looking on each cluster on each cluster to the same 2 queues, and we saw that the workers were getting the jobs in the even manner. We were not able to see that, let's say, some server, specific server gets all the jobs. For example, we had some comparison with the Rabbit solution. In case of Rabbit, this was not the case. In case of the Rabbit, the server, few servers, the first of them tend to take all the jobs. In case of Jesque handled it in the good way. So why delayed jobs? Delayed jobs because in the peak hours, usually, even though we are running user request before a scheduled request, it can be the case that we are getting few heavy scheduled requests without user request, and then we are getting user request. Now, scheduled requests already run, and scheduled requests are using the shared resources. Actually, they are running the queries over the database, which means that at the moment we get the user request will try to run the query on the same database, and it will be rather heavy because of shared resources already, of scheduled jobs already running. So what we would like to do is for scheduled job, first of all, to check whether we have resources, and in case we have resources, we would like to put our jobs into the queue, but not for immediate execution, but for execution in some future times. For example, we can put the job to the queue and say the job will be executed in 1 hour, in 2 hours, something like that. And it was very handful because actually we have some flow. We did not need to change our flow. It's just the scheduled job just going and checking whether resources are available. In case resources are not available, we are putting the jobs to the queue in some transparent way, which means they are in the queue actually, but our workers can't see them until some time in the future, until 1 hour, 2 hours in the future. So it's very useful because you actually don't need any special flow for such a jobs. You're just putting on the job the time when you would like the workers to see them. And in this way, you are getting the required behavior. That's the delay jobs. And the bonus feature that we get from this solution, we get distributed cache. Redis distributed cache, we used it in few places. For example, we've based our semaphore solution that checks whether we are not running too many queries on specific database. We are based it on distributed cache of Redis. Additionally, we've put, at the moment we are drawing the job from the queue. Actually, if in this moment the server fails, we are losing the job. So we would like to save footprint of the job in the persistency, And in the case of the failure of the service, we would like to go to the persistency to bring the job and to revive it in some way. So it was very easy to perform it in Redis. So these was the things we get in addition, actually, to our requested behavior. That's the problem, that's the solution. So.